Welcome everybody. Welcome to our another lecture in hash table. So actually this lecture will be the continuation of my previous lecture, and then in this lecture I will make a correction in my previous lecture that I did a mistake, slightly mistake, and then I will go through with few more examples. Okay, so let's get started. So okay, so in our previous lecture actually we discussed uh, open addressing with linear probing and uh, quadratic probing, right? Probing. So here at the end of our last lecture I noticed that I did a little mistake, so let me first correct this. So here, so these are our key value that we are talking about, right? So 2, 7, 9, 6, 13, 3, 11, 12, 23, 25, and so on, right? So if we use in modulus operation, division operation with modulo operation, so then then actually what will be happen is, if we consider m equal to 10, then here for, and then if our our hash function is either like h of k equal to okay, k modulus 10. If it is 10, so then what will happen? So for this one, 13 modulus 10 will be 3, right? So here instead of, so 13 is coming here, so actually 13 will not be coming here, and 12 will not be coming here actually, and 11 will not be coming here. So 13 modulus 10, so 13 will come here. Actually let me it does this. So this is my table. Okay, so 13 will be placed over here. So 13 modulus 10 equal to 3, so 13 will be placed as position 3, so 13 will come here. And similarly 12 modulus 10 equal to 2, so 12 also will come here, right? 12 also will come here. And then like 23 will come to this position, 13, then 23, and then also 33 will come in same position, 43 will come same position. Okay, so that's the correction. So I should not have this for these positions, actually 10, 11, 12, 13. Actually what happens, the rule of thumb is that if we, what is the m value we should consider? So m should be the how many numbers we can have. There are two ways. For instance, we can consider m as the largest key value. Okay, for instance, largest key value initially was 14 over here, so we are considering 14 over here. So but if we consider the number of key values, how many key values over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for instance, 9 or 10, whatever key values is. For 10, if we have 10 key values, so we can say modulus m equal to 10. If we have 14 key values, then we can say 14 modulus m equal to 14. So that is the rule of thumb. So for instance, with this correction I can say m equal to 10. Okay, so now I hope you can make this fix. Okay, and actually in the video so actually in this lecture video I have this mistake, so please make your correction. Okay, so here in this video, so please make your correction, and then I think this correction is easy fix. Okay, now let's continue the remaining discussion. So in case of linear probing, if we say h of k equal to k plus I modulus 10 or modulus 10, if we say m equal to modulus 10, then I value over here, so linear probing, so we say k plus I, right? I value equal to 0 to m minus 1, that means m equal to the maximum value equal to m equal to 10, so 0 to 9. Okay, and dot 9. Okay, and so you may check that for some key. Okay, for if you go with all of this one by one, you may find that for some keys there may not have any empty space. Okay, so in that case there is no way for simple hash function or probing function, okay, or hash function, for instance. Let us check for a few, like for instance what we said in our last time. Okay, let me erase, let me get some space. Okay, for instance, so we are considering our linear probing, linear hashing method. So these are our key values. Okay, so I redraw this. So 2, 7, 9, 6, 13, 3, 11, 12, 14 and 8. So for instance we have 10 key values, and so in a simple hash table we can have 10 locations, 10 size hash table with size 10, simple, right? So apparently we can say that each of these key value will be located in each of these location, right? But if that depends on the situation of the hash function we use. So if our hash function is very simple, like h of k equal to k modulus 10, okay, so then what we'll see that 2 will go in this position 2, right? And then 7, 2 will go in this position, and then 7 will go in this position 7, 9 will go its 9 position. It's simple hash, right? So 6 will go its position 6, 13 will go, so 13 modulus 10 equal to 3, so 13 will go here in this position, and then again 3, right? So 3 is 3 modulus 10 equal to 3, so this 3 position is already occupied, right? It's not empty. So the two ways we can do, we can make a linked list over here in every location, that with that linked list we can put 3 also here. Okay, 3 also put over here, Okay, then 11 will come in this position. 11 modulus 10 equal to 1, so 11 will come over here. 12 or again 12 modulus 10 equal to 2, so 12 should be coming in 2 position, right? So so let us do it simple. 12 will come over here, and like 14 will come at this position. 14 will come at this position, and then 8 will come in this position, right? Okay, so whatever we see that apparently initially we thought that each of the key values will take location, its location. For instance, it's location u. Okay, so location in the location table, each of this cell values, right? But it is not happening because due to our simple hash table hash function. So simple hash function, so there are some empty spaces. These are empties, these are unused, like this is unused, 0th is unused, 5th is unused. Okay, and at least 2 we got unused, and then we see that some positions already is getting complicated. We are not simple, that we need linked list data structure over here to put double values over here, right? So in that case, what we can do, there are multiple ways to do that. For instance, we introduce the probing method, and then we can change hash function. For instance, if we consider instead of this simple hash table, if we have another hash table hash function, for instance h of simple, for instance, if our hash function is something different, whatever we say, for instance, if we say it's our hash function is 2k plus 3, anything you can do, okay, modulus 10. So then for instance, then you will see that for let us rewrite this. For key value 2, right? Okay, for key value 2, okay, so then key value 2k, that means 2 times 2 4 plus 3 7 modulus 10, okay, 2 times 3 plus, okay, 2 times 2 4 plus 3, okay, modulus 10. This will be 4, 2 times 4, 2 equal to 4 plus 3 7 modulus 10 equal to 7. So 7, 2 will take place in position of 7, okay, so not in 2. According to this hash function, 2 will take position in the new hash table 7. So let us make this, delete this, okay, and then rewrite this, because we will have something different, okay. Okay, so 2 will get in position 7, okay, that is not a problem. Whatever our hash function is, our hash table will be redesigned accordingly, okay. So for 7, now 7, for 7 what will happen? For 7, okay, 2 times 7 plus 3 modulus 10 equal to 7 times 2 14 plus 3 17 modulus 10 equal to 7, okay. Still that we can we see that 7 will come over here, or we will see that we can, if we use probing, then we can have an alternative way that we can use these empty spaces. Okay, we can use empty spaces. For instance, probing, if we use probing, then I'm coming soon, okay, about probing. So let us see for some other stuffs. For instance, 9. Okay, so 9 equal to come where 2 times 9 equal to 18, right? 18 plus 3 equal to 21 modulus 10 equal to 1. So that means 9 will come at position 9 over here, right? And then for instance 6, for 6 you will come 2 times 6 equal to 12. 12 plus 3 15, 15 divided 15 modulus 10 equal to 5. So this will come at position 6 will go at position 6 will go at position 5. Okay, and let us see, and so on. Okay, and but as we have found that for some values, for instance 2 and 7, they are still locating same position here, right? 2 and 7. So oh, I'm sorry, there would be 2 over here. Okay, so 2 would come over here. Okay, so 2 and 7 are coming, these are coming in same position, right? So that means still we have same problem with this hash method, with this hash function. Still we have problem that we need a more complicated data structure in these cells. So that means if a complicated data structure is needed in one cell, that means we may implement that in all other cells. Okay, so that is a little bit complicated, right? So in order to resolve that problem, what do? That we know that we use probing, right? So in linear probing, that means instead of doing this one something, for instance this like this kind of sample hash function, we use a different type of hash functions. For instance, okay, okay, for instance we can say h of, okay, let me write it down here. Okay, for instance we can say h of k. So what was our function was h of k equal to, we have 2 k plus 3. Okay, so 2k plus 3. So this one we can say h of k. Okay, h1, for instance h1 we can set to 1. And for probing also, probing, okay, so instead of, we have about like this, right? Modulus 10, modulus m, whatever we set, m or 10, whatever we say. M. So this is our EU, or we consider this is our function for EU. Okay, so but instead of like this, so what we use, h of k equal to this u plus, we use another function v, for instance v of maybe v times I will be using for index, for for probing, and then we will be using like this modulus m. Okay, so then for instance if we say b equal to is another function. For instance b equal to maybe b equal to it's very simple. It can be is to k modulus again maybe m. Okay, okay, so here that means what is our total like hash function is going to be. So hash function is going to be something like so then our hash function is going to be h of k equal to, we will say u like the u plus b I modulus 10, right? So that means 2k plus 3, that means our u plus b is in simple, right? So b is in simple, so we can say k plus so we can say k times I and then whole modulus m. Okay, so now with this, or actually you can consider any hash function whatever you like. Okay, so with this kind of modified hash function, what we'll be doing, so for instance our I value will be, remember that I value will be 0 to 1 to less than m minus 1. Okay, m minus 1. So for instance if we consider m equal to 10th, so then I value will be 0 to 1, 0 1 2 3 up to 9. Okay, so then our goal is to use the unused space, but make do not use the to skip, to avoid of using like complicated data structure, so that complicated like linked list data structure like this. Okay, so now for instance let us see what will happen for the key 2 and 7, where we are getting problem, right? So for 2 what we'll get, our data function, our value will be over here, the location will be, so for 2k plus 3, that is 7 plus k equal to 2, so that means 2, let me write on 2 times 2 plus 3, okay, plus k equal to 2, and initially it is going to 0, and then modulus, whole modulus 10, that means this part is 0, this part is 0, but this part is 2 times 2 4 plus 3 7, so we are getting first at 7 position, right? So as we find 7, if we find 7 location is empty, unused, so we will put 2 over here. Okay, so we will put 2 over here. Okay, now for the 7, let us see what happens for 7. 7 is 2 times 7 over here plus 3. Okay, so then 14 plus 3 17. Okay, 17, and then plus 7 times 0, and then whole modulus whole modulus 10, right? So that is 17 times 17 modulus 10 equal to 7. So as we see that 7 is occupied over here, this position, so then what will, so we will look for the next available position. Okay, So next available position will be here. So what will be here? So then in that case I will be used. Okay, so this part will be same, but I will be used. So I will be, initially I was 0, then I will be increased to 1, next 1. Okay, so that means then alternatively we will go that 14 plus and then 7, right? 7 times 1 equal to 7. That means we will get 21 modulus 10, we will get 1, right? So this one position is again it is okay. So so for instance, if it is used, so if we see that if it is already used, then we will again increase for I equal to next, I equal to 2. And for this, in this case, I think this value was for previous hash function, so I can delete this value. This value was previously. Okay, so now we see that 1, right? 1 position is right unused, so 7 will come over here. Okay, but if this position was used already, then we will increase I. Okay, I again, and then we will go for the next look for the next empty position. Okay, so the I will be, so in that case for 7, what will be the prob value? Okay, the prob value will be so in the first hop we did not find it, right? So that the first hop, one step, first landing position, we did not find it. So then we have to increase I. Okay, so just here. In our first landing step for 7, we did not find an empty space, so we need to increase I. So that means prob will be, for this one, prob will be 2. Okay, so then if we say this one, if we write prob, if we need to write down prob, then will be 2. Okay, and similarly you can easily find out for the other variable, other key values. Okay, and then for each key values you will see, hopefully you will get an empty position. So whatever the nearest empty position, then you will get it. So then whenever we have prob value and then we have our hash function, then by using this combination of prob value and hash function, we can locate our actual location of the key value in hash table. Okay, but one thing is that, remember that, I don't know for which one it will come up. For some variables, for some key values, you may not, still using this kind of hash function, you may not find any available space. That means maybe it may happen that we will be increasing our prob index. Okay, I index, and then we will be increasing from 0 to m-1, and then we will be coming back again in occupied position, so there is no guarantee that for a specific hash function then we will get we will be able to allocate all of the key values in a perfectly in hash table. Okay, so that is the limitation. Okay, so you can try with for other values and you may find something. Maybe for some values we may get something. Okay, so this will be your assignment. Then I will give you some key values and then we will ask for to find location and prob values. Okay, and then you may find that there is no position for some variables, some values for So now this is a problem. So in order to resolve that problem, so we can use a different probing function, or so the one of and the position probing function, another probing function we say is quadratic. Quadratic probing. So quadratic probing means over here, so in linear probing we are using I is very simple format I, right? So in quadratic format you will be using I something like in a different method. For instance, using, you can say h of k equal to, you can use a quadratic function, for instance 2k, whatever you say, use 2k plus 1 or 2. So you know that hash function, you can use any hash function as you find comfortable with. Okay, so for instance this one you can say I squared. Okay, you can have k over here or not k over here. I squared plus maybe 2k. Okay, this may be 2ki. Okay, and then your total will be modulus m. So if you use this kind of like different hash function with, say this is called quadratic probing, right? So this I, so this has power 2, this is quadratic function. Okay, and then definitely I will be 0 to m minus 1. Okay, I value will be. So then using a quadratic probing function, hopefully we will get a space for each of the key values, but there is no guarantee that we will get it. Okay, so but you can have a try. Okay, so now let us go back to our book. Okay, so in our book we will see that there are some theories behind hash functions, and then okay, one of the this kind of hashing is actually the last one I discussed, that is called double hashing. Okay, double hashing is means, so here this one, so double hash function. Okay, so this one that I discussed recently, this one actually it is also called double hashing, because we are hashing both both our main hash function and then probing function. Okay, so we can say this double hashing. So there is a term double hashing. Okay, yeah, so please read, go through the book and read for double hashing, and then you will see that double hashing is maybe is better, a little bit better, but there is no straightforward rule that you will use hash function. So whatever hash function you like, you can use, or in the assignment I can give you a specific hash function to go with. Okay, so as I said that in this, and there are many research going on hash functions. So there are other hash functions like static hash function and other hash functions that are considered is better or more complicated or newer hash functions. So I may not, we don't need to go all of this. Okay, so our goal in using hash function is that, remember that what is our goal of using hash function is to minimize our search time, right, in a data table. Okay, so I added this slide from Professor Lee, so please go through this slide and then you will understand the same thing that I discussed in our lecture. So another thing is that For instance, hash function is used not only for a specific data, it can be used for any kind of data. For instance, if we have a data set with numeric data set, okay, sorry, with a string type data set like names Tom, Dick, Harry, Sam, and Peter, okay, so then how the hash code or hash table will be generated, that depends on you. Okay, so you can use, for instance, you can say, for simplicity, you can say you will use character ASCII value. So for the ASCII table, so if you do a Google search about ASCII table, you know that ASCII chart or ASCII table. So according to ASCII table or ASCII chart, we can develop our so for instance, in ASCII table you see that capital A, okay, that one, not that one, okay. In ASCII table, capital A has position 65, decimal 65, okay, and lowercase a is position 97. So lowercase is position is 97. So A is 65, B is 66. Then what is T? T is 84, okay, and lowercase t is 116. So if you use, for instance, for Tom, if you say the ASCII value of uppercase T plus ASCII value of O, lowercase o, plus ASCII value of lowercase m, so then you can do that. So get each of the individual ASCII values and then you can plus sum them, add them up, and then you will give a hash value, hash code, okay. Or you can multiply them, or whatever formula you use, or you can put one after another, okay. So whatever you like. For instance, here, whatever you like, you will create your, you will use same formula for all of these key values, and then you will apply, you will get some numeric value, and now you can apply, for instance, now modulus 10. So if you modulus 10, if you use modulus 10, then we will get the right digit 2, right? The modulus 2, and then here 9, and then here 8, and then here 5, and then here 8, and then you can use then any hash function to generate your table, okay. Okay, so they are using m value here is 5, so no matter, you can use m value 5 or using 10 is very simple, right? So whatever you use. So if hash table, if you use m equal to 10, then remainder will be 4 over here. So this is 4, and then this is 3, okay, and this will be 0, and this will be this should be also, okay, this should be also 3, okay, there's a mistake over here. Okay, so please go through these slides and then remaining slides, then you will see that okay, it has actually why do we use linear hashing, double hashing, and coordinating hashing? We will use to find the next empty cell so that we can minimize the size of minimize the use of a complex data type, and we can use unused space, okay. So please go through these slides and read the book, and then you will see, oh, actually what is the term? There is a term that whenever whenever a value, a cell is already occupied, and then that is another key is coming to that cell, that is we say call, the word is called, terminology is called collision. So if collision happens, then if collision is detected, then we use probing, okay, and then or other hash function, okay. The term is called collision, okay. So when resolve collision by chaining, that means using linked list data structure, or okay, so we can use probing method to use the next empty space. So for analyzing chaining, that means if we need to use linked list data structure, then what we will see that still we need to go to land to our hash table in fast landing, that is that will take in constant time. After that, what we will need, we need to go to the probing, like to few more steps to go to the next empty space, right? So in order to go to the next node in our chain. So in that case, so we may need a little bit extra time, but still the time is pretty constant. Okay, pretty constant, not linear. We can say here 1 plus alpha, or you can say I or alpha, whatever you say, that is okay. So making a good hash function is a good way. It is a good way to look for good hash function. So the rule of thumb is that a good hash function should distribute the key uniformly into the slot of the table, but again, it always may not be happen. Irregularity in the key distribution should not affect this uniformity. Okay, so actually so I discussed this, the division method, and then and then why do we use collision? Why do we use hash function for open addressing? We say open addressing to avoid collision. What is collision? If there is in the hash table, if the initially found position for a key value is already being used by another key, existing key, so then we get a collision. And that in order to resolve a collision, we use either another hash function, good hash function, or we use open addressing. That means with probing or double hashing, or we say linear probing or a quadratic probing, whatever you say. For quadratic probing, I squared. Okay, so that means you need to have an I. So that means your jump will be not linear, not one after another. It will be for few steps together. For instance, for I equal to 1, I squared equal to 1, right? For I equal to 2, I squared equal to 4. So then it will look for the big jump. And then I equal to 3, then I squared will be 9. Okay, so and then I discussed double hashing, that is using for both two hash functions together. That is a complicated hash function. Okay, so there are some examples here for double hash function, and for double hash function we need to use probe. Okay, so when generally if we find our empty position in the hash table in the fast landing, then probe value is 1. But if we do not get it, and if we need to go to use I values, okay, to increase I values, then we get more increased probe. So that means here we discussed that for this one, I probe equal to, for 7, probe was 2. Okay, and then you can see you have a total number of probes. Okay, so in your assignments, I will give you some values, and I will ask you to find to use a hash function and find the probes. Okay. Okay, so that will do our discussion about hash function. So please read the book and then slides, and then I will have a assignment for you. So the assignment will be all from the content from, let me go to okay, as you see that I updated schedule. Okay, so please take the quiz. Please take the quiz 4 by this weekend, and by next weekend you have to complete the assignment 4. I will upload assignment 4 by this weekend, and then assignment 4 I will give data structure. I will include all of the component for data structures. Okay, this is why I deferred assignment 4, so that I can task linked list, stack, QE, binary search tree, double red black tree, ABL tree, and a hash function in assignment 4. Okay, so please be ready. Assignment 4 will be maybe a little bit longer than previous assignments, but you will get a week to complete it. And then we have in our next few weeks we will discuss graph algorithms, some graph algorithm, and especially the dynamic programming, and at the end we will discuss NP completeness, and hopefully, okay, so please follow the schedule, and you will have a test 2 on D2L. So at the in early April, okay, at the beginning of April we will have test 2, and I'm thinking how to make the test 2. So maybe test 2 will be open book, but we may use this time lockdown browser. So you will be able to use book or use your class note and our cheat sheet, whatever you use, but you will not be able to use internet, and then you will not be able to get help from anyone else. So you have to do it yourself. So you need to use, in a test 2 you need to use lockdown browser, but it will be open book. So you may buy the textbook or take the printout this, or you may use another device to open the book, but you always, for the entire test time, you have to keep your camera on and you have to look on your screen. Okay, so I will allow you to use any note or cheat sheet or whatever you want to use, but since you will be using lockdown browser, you cannot use your own like computer for opening this book, so that whatever you can see, you can think about it ahead of time. Okay, so you can take a print out of the book, or you can buy hard copy of the book, collect hard copy of the book and use that book, or you can use a note. But one thing is that you need to give your focus, so that we can have your picture and video, your webcam on all the time. Okay, and thank you so much, and I hope you will be able to understand hash table. Okay, thank you so much, and I believe when you complete your assignment, then you will get more clear understanding about this. Okay, thank you so much, and you have a good day.